Hello class, in this video I'll be showing you how to find the derivative of a function using the limit definition. Let's begin. The derivative of a function is a function that measures the instantaneous rate of change at any given point x. The derivative of f of x at a point x is defined as the following. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x divided by h. And that's provided that the derivative exists at x. Okay, so what I've done is I've gone ahead and provided the steps you're going to need to find the derivative of a function using the limit definition. These steps do not have to be memorized because in later sections we're going to find more efficient methods to finding the derivative. So when you take your exam, these steps can be in front of you. Now I'm going to show you how to use these steps to find the derivative of a function. It says, use the limit definition of derivative to find the derivative of f of x is equal to 3. Now f of x is equal to 3, this is a constant function. So no matter what you input in for x, the output is always going to be 3. So if we were to input x plus h into the function, that output would also be 3. Next, we're going to take f of x plus h, and we're going to subtract f of x. So that would be 3 minus 3. So in this case, that would be 0. Step 3, we're going to take 0 and divide it by h. And 0 divided by h is 0. Finally, we're going to apply the limit. So the derivative of f is equal to the limit as h approaches 0 of 0. And that equals 0. So you're probably wondering, why is the derivative 0? Why did we get an answer of 0? Well, like I mentioned earlier, the function f of x is constant. It's never going to change. Your output values are always going to be 3. If we take a look at the graph of f of x is equal to 3, notice that is a horizontal line. And the slope of a horizontal line is always 0. Hence, the derivative is going to be 0. Next example. Use the limit definition of derivative to find the derivative of f of x is equal to negative 5x. So the first step, f of x plus h. I'm going to substitute x plus h in for every x in my function. And the result is negative 5x minus 5h. Next, step 2, we're going to take f of x plus h and we're going to subtract f of x. Okay, so notice f of x, which I'll make green, is negative 5x, which was given. And we're going to subtract the negative 5x. So this becomes negative 5x minus 5h plus 5x. So the result is negative 5h. Third, we're going to take negative 5h and we're going to divide it by h. And the result is negative 5. So the derivative is the limit as h approaches 0 of negative 5, which happens to be negative 5. So the derivative is negative 5. And you are probably wondering, why is the derivative negative 5? In the previous problem, the derivative was 0. In this problem, the derivative is negative 5. Well, if we come over here to Decimus and we graph negative 5x, what is the rate of change of this function at every point x? Well, if you said the rate of change is negative 5 because the slope of this linear function is negative 5, then you're absolutely correct. So since the slope of this linear function is negative 5, the derivative is going to be negative 5 at every point x.